Okay, we are back live. Hi. So there's a bunch of stuff to fix right now. Um, this looks like something I broke, and the packaging I don't know about, but this looks like something I broke. The only thing I can think of for this, we're getting this like random seg fault now, or this random CUDA error. The only thing I can think, I did make some optimizations to this file, I don't know, a week or two ago. So if we just compare this to like dev, I think this branch also has, yeah, this also has the optimizations in it, right? Okay, let's go back a few commits. Not that many commits here. So this one must be fine, right? You would think. Actually, hang on, wasn't this only 2 weeks ago? March 16th. No, this has been here a while. So it could technically be this, but it's unlikely. Let me see this versus... Just compare these two a little bit. So this is for a discrete action space. You get normalized logits, this code's identical. And then this is logits to probs of normalized logits. Oh, this is wrong. This should be on logits, not normalized logits, right? Wait, how the heck does this still work then? Logits to probs of normalized logits. Man. Minus log sum x. Yeah, it's just wrong, right? So then this goes into probs. This should just be logits. And then probably everything else works. Okay, and the multi-discrete, it's possible we broke things here as well. Let's see if this still gives us blow up. Also, why is this 1.5 mil steps a second? Because this matches, but this is too slow. Whatever. Let's see if it is, if this is stable now. This can't be the bug that Aaron had because this is in the torch code, right? Yeah, this curve matches. I mean, this could totally be the thing that broke it, but it would be a little weird. I also don't know why it's slower now. Oh, these are not the optimized settings. Wait, these are just the defaults. Okay, yeah, this is totally fine. Yeah, this is totally fine then. So let's just give this a few runs. We'll see if this breaks anything. And then in the meantime, let's see if we can figure out why the build doesn't work. Because when I'm on this machine here, machine doesn't want to build. So we have an issue in PyBind. Pi buffers undefined. Okay, so that looks like a python.h is not included. No module named torch. Really? Build meta. But there is a torch. And not commit something. PufferLib PyTorch. No, we have everything checked in. Okay. Or the extensions. Okay, so we still get this no torch. Git build requires. That's bizarro. Okay, it's not a Python versioning thing. Hmm. Can I just like import torch? Okay, so no module named torch even though I'm importing it. Lovely. That's still not working. See, this is all like people not being able to install torch. We have torch. Oh, I guess that this wouldn't be... You wouldn't use this if you're just installing the Python backend, but still we have this issue. Gotta be this, maybe? Okay, so now we have something else. This seems to be like an issue with Python itself. Setup tools issue. This new warning in Ubuntu is really obnoxious. Now we're on setup tools 80 somehow. Okay, we still get this issue here. So update import lib metadata. Python packaging is like truly awful. No, we still get it. Nah, there's only one live stream. Nobody else is streaming. Is this the same bug then? Because this is... Still getting the issue. This is in distutils. Hang on, can I do -u distutils? This was removed in 3.12. Setup tools /dist. Oh, this is actually me being dumb. Yeah, this is actually me being dumb. Cool. Alright, so this part builds. And then if I do... I think if I uncomment torch, then it breaks. No module torch. Can you put breakpoints in this thing? No, you cannot. So you should absolutely be able to import torch. Because I have torch on the system. And we have CUDA available as well. You shouldn't even need CUDA available to import that, though. It's bizarre. Hmm. First installing Xformers. We shouldn't need this. I can't take torch out of... Or install requires. Do I add it to here? I mean, it would be weird. Yeah, no, see, even though it's listed in install requires... Do we not have, we have a toml, right? Hmm. Maybe it does. Maybe it, like, builds the package. Maybe there is some difference where it, like, builds the package in some isolated environment. Because it looks like it's installing a new version of Torch there to me. It's taking that long. So the more you know, even if you have a package installed, apparently it can still break if it's not listed explicitly. I'm gonna give this a minute or two. I think it's possible that this is just taking a while to do a completely fresh torch install. And I forgot I had myself muted. Okay. So for some reason, this setup is separate. We got it working now with the install requires edition. See? Do we not have CUDA available? CUDA works. Do I need to add this stuff into build requirements or something? It would seem very weird that this is like totally unknown error. Eh. Oh. Again. See, this is why I keep the hours a little shorter when I'm doing this type of work, because it's so, like, monotonous that I make dumb errors, and I get stuck on silly things like that. Like, I'll just change something for testing and forget to change it back. I enjoy most of the dev work for Puffer, but pre-release stuff is just a pain. Because it's when you have to, like, fix all the fiddly bits. Okay, so now at least this looks like it runs. We'd still have a setup error here. No, this is on Puffer box 0. Wait, no, this is mine. Okay, Puffer at... Why am I on Puffer box 0 here? Okay, yeah, this is totally different. And this is still running, perfect. This is still erroring on us. Hopefully with something more reasonable. Okay, so this is where we get a ton of actual error messages. So we're compiling torch extensions with the correct command class. Let's see if we get the full error trace. Yeah, so this looks like it's not getting the .h file, right? Pi buff strides undefined. Yeah, that comes from the .h file. So we have PufferLib C++, PufferLib.cu. C++ includes .h. It is entirely possible that there are build errors, and like I had some cached build on my local machine, and that's why it was working. So we're going to be very careful that we replicate all of this. And then we're going to make sure this works on my local, and if it works on both of them, then we're probably good. Okay, so we are now getting... Are these different errors? No, PyBuff strides under this. To me, this looks like yeah, this looks to me like Python not getting included. So I have python.h now. Let me see how they do it. There is a repo for this. Where's the repository? Okay, so this is the tutorial thing that they put out. What's their CUDA include? Okay, so their CUDA does not need the Python. It wouldn't make sense anyways. It's CUDA code, right? So they have torch extensions, CUDA.h, and CUDA runtime inside of an appropriate namespace. What we have. And then here, they have python.h, A10 operators, torch all, torch library, and vector. So we have identical setup. Do they have a toml? Requires setup tools and torch. And then setup tools build meta. So this is the same. Let's see if there's anything else I missed. Or if we get something reasonable up at the top. Not compatible with the current PyTorch installation. How did this happen? No, we do have Torch 2.8 dev with CUDA 12.8. Yeah, this is CUDA 12.8. So, oh, you know what it is? I know what it is. Can you just do like this? Or... Hey, how's it going, Ivy? Um... We'll see if I can just reference this specific version. So I think what happened is the requirements build version of Torch is not matching our current version of Torch, and as a result of that, it's trying to build the CUDA kernel with the wrong CUDA version. I'm pretty sure that's what's happening. Yes, hello. About a year? Okay, so you can't... So how do I specify a nightly version? Actually. Need to point. Yeah, so this doesn't work. Okay, so most tools create an isolated build environment and build system. Okay, fine. I don't want frickin' additional build dependencies. God. Yeah, this is just like... How do you just... Maybe I can just do it this way. That's like crazy obnoxious. Also, why does this just randomly stop working, huh? I swear this, like, these LMs are just dumb. This still doesn't work. So you just wrote it just wrote a bunch of spam, basically. This still doesn't work. I'm pretty sure you fail on import torch here, right? No build isolation. Let me see if this works first. Because then I can just add a note for 4090 users or whatever. And now we get here. We still get this error, really. Because it's still going to use the isolated build version. I have the correct dev torch right here. Okay. If I remove it entirely. Then we get the same thing. Hang on. Let me just make sure that this is actually the error. I was pretty certain. But now I don't get that same... Wait, I don't get the message from before about CUDA version compatibility. Now I'm just getting like the generic error, I guess. Okay. Do I get, if I just add like any torch here, do I get it? Fucking CUDA, man. I should see some sort of issue with the CUDA version. It's weird that I don't get it here, but if I remove this flag, I should get it, right? So let's see if I have CUDA capabilities. at the top. Okay, wait. The detected CUDA version has a minor version match. Oh, wait. Here is the error. Maybe I just missed this before. So this is absolutely bad build isolation, right? So if I do with no build isolation, it should use my Porch version. Let's just see if I missed the error message. And you can see, oh, no, I did miss it, right? There are no, okay, that's fine. Okay, so this is using CUDA 12.8. But we still get the error. The 120, yeah, so this is the correct compute architecture. So this is compiling specifically on a 5090, right? So maybe this is not the error I thought it was. Maybe this is actually hardware-specific compilation. CUDA 12.4. High buffer. Limited API may exclude certain C API types. Okay, I'm doing this. Disable dpi limited. All right, let's see what this does. Successfully installed. $3.8 million steps per second. Perfect. So it was actually the limited API stuff. All right. That was annoying, but it looks like we have stable sweeps running here. So here's what we'll do. We're going to commit this fix. I'm going to push this. Egg. I don't know, some tag. So this runs. I'm going to let that, so we can reattach. So I'm going to let this run. I'm going to go do a few things, take a quick break. Clear my head of all this mess. When we come back, I will monitor these breakout results. We will integrate all these build fixes. We'll test them on my local as well. We'll see if we can get this compilation to play nice with the environment compilation, because that's still an issue. You know, not necessarily what I wanted to do today, but we have to do this before release anyways. So, like, fine. And it'll give us time to run some sweeps. So, I'll be back in 10, 15-ish. And we will be good. Get a couple little bit of exercise, walk around a bit, all that. All right. I'll take 155 for 20. I can't load it heavy because what I'm just, when I'm streaming, I'm not warm, so I keep it light. It's still good for getting some extra exercise in. All right. Detach this. I did a little bit of Aikido in college. That was it. Oops. Looks like meeting. All right. First of all, how are our experiments going? So, this was the old sweep. We have some data in here. Oh. Yeah, that's already finding stuff, right? Now, the real kicker here is wall clock, right? That's a 30-second. That's pretty good. So yeah, we will just see how this goes. We'll let this run for a fair bit longer. We can kill... We don't need this one anymore. We're just going to run this new set of sweeps. And we will see what this comes up with. All right, so next thing is... applying these changes to our local. So this requires torch. We take off limited API. Add this for now. We take this option off. That should be the whole diff. So now, close this. See if that builds. Yeah, it builds, but I think it was cached. Either way, we commit that for now, for sure. And then you just have to do no build isolation on a 5090, which I should add a comment to this. All right, now we at least have a version on which we can run some experiments. So from here, we should probably, what do we think, maze? Maze could be a good one. Quite a bit of inconsistency in it, I suppose, but just doing a sweep on maze would be good. We could do a sweep on meta. Meta would be good. That does require a whole separate build environment, though, so I think we'll wait on that until we have everything else stable. We could also do neural MMO, but I think we've seen that we actually have to sweep quite a long time on that to be sure anything's working. Maze would probably be a decent one. There's a whole bunch I want to do, though, with like the replay priority and all that. Maybe we take a little step back and think a bit. I've got 2 hours before meeting, and then after that I'll have another 2-3 hours, and then another 2 later. Let's figure out, like, prioritize some of the release stuff that we need to do. So the main things that we need to ablate are hyperparam sweep, advantage filtering / new advantage algorithm. Is that all? I think it's those 3 things. Really, it's just hyperparam sweeps, and then ablations on prioritized replay. Now, the tricky thing, right, is we'd like to have some good EMs to test this on, but our easy ones have become too easy since the new version is so good. And our harder EMs still take quite a while to train. It should be a pretty easy on-off thing, I think. Yeah, it should be a pretty easy drop 1 ablation, I think. So, testing our new advantage function is actually quite easy. Prioritized replay, I think we can sweep. Yeah, we can totally include that in sweeps. We want an env that takes a while to train, but not too long. The thing with breakout is, like, once you start getting under, what is it, 80 mil steps? Well, no, actually, with the way breakout works, I think you should totally be able to be more sample efficient than we currently are, even with the number of M's. I guess it's just like, it's only 100 updates or something, 100 full updates. The mini batches are pretty small, though. Okay, we could try prioritization. That's a thing we can mess with. That's easy enough. The thing that's difficult here is, like, what do we compare? Do we compare fully tuned run with and without prioritized replay? I guess that would be the most fair thing to do, right? And then we would want to pick... We'd want to pick, like, a nice suitable env for it. For initial experiments, and then run them on several after. Maze is the best one. Maze is, like, absolutely the best one. So I think what we do... Where's Prio? I think it's like Prio Alpha. Yeah, so there's Prio Alpha. And Prio Beta 0. Yeah, Prio Alpha, Prio Beta 0, so we just do... I think these are both 0 to 1, right? So it's logit normal, maybe? I think they are logit params. So 0.6, 0.4 we can do. 0.1. This will auto scale. That's pretty good. Make sure that this distribution stuff is set up correctly. It looks to be. All right. I bet that this is a multiple key error. Yeah, it is. So what did I replace this with? So it's vec backend is multiprocessing, right? All right, so let's get rid of all the vec stuff. Okay, 1.8 million. So this maze training seems like it mostly works. It's almost working too well, in the sense that, like, you know, you wonder if there's any perf to be gotten out of these optimizations here. But I don't think it'll full solve, right? Unless we've just magically made everything way better. Looks like maybe we have made everything magically better. Always nice to come back to an environment once you've made library improvements and just have it be like amazingly well solved. I actually want to watch this policy back, because I don't know how it's doing that well. That's like pretty darn good. And with default prioritization, 97%. Yeah, we'll watch that one back. Hopefully I haven't broken rollouts. Oh. Yeah, it's just a really good policy. What the hell? That's like an amazingly good policy. What? That thing backtracks like really, really well. Huh? I mean, yeah, it missed one turn in this end, and it still eventually got it. We didn't, like, mess up and put some extra reward in, right? I haven't modified this. Yeah, we kind of just crush it. So we now magically have a good maze policy. I guess we will see. If any env is going to matter the advantage filtering, it'll be this one. I don't know. A siren going off. My filter caught it, but... What happened with this? Oh, it needs to load a full-size map, I guess. That's a render bug. Hang on. Max size, I believe. Okay, so this gets multiplied. We'll do like this. And then maybe I can record it. Got this. That's kind of insane. I actually didn't expect it to be able to do that well. That's like a really, really good policy. Is it videos? Screencast, maybe? Oh yeah, this is it, right? Yeah. Rid of this bot. All right. That's gonna be tough to beat, honestly. Let me try one thing. Oh, it's a bigger model. I see. It's a bigger model. If this actually solves anything, I will be amazed. This should be able to get roughly 50%. So actually, I think it's higher because, well, hard to say. I'd have to think about it. Let's see if we at least get a stable training curve out of this thing. And this might be too hard, this one here. I might go to like 47 or something. Okay, so this actually, I mean, it's training something. But the success rate is kind of too low. You kind of want something with middling performance, where there's like room for improvement, but you're not worried that it's just going to hard fail repeatedly. So we'll go to 47. Let's see how this does. If this is good, then what we'll do is we'll launch a sweep on this with the prioritization. Immediately more stable. Yeah, I know. It's like, I just ran defaults, Captain. This is what I mean by like... Like, I'm pretty sure that's better than anything non-specialized ever published. Yeah, that's a ridiculously hard problem for RL, and we kind of just solved it. I'm now training it on 48 by 48s, up to 48 by 48s. Oh, also, I trained that policy in about a minute and a half. It's a 2 million... Mind the background noise. 2 million parameter model training at 1.7 mil SPS. Yeah, it's just defaults, Captain, pretty much. I forget, actually. Do we have all defaults? Okay, no, there's a custom, like, a couple custom params in there, but not much. I don't think it's a good sweep, either. Why did the puffer stop? I guess it just gave up. Yeah, so this one is not quite as good, I think. But these are much bigger mazes. It's not quite getting the level of backtracking it needs. This will be a good challenge. Why would you have a no-op action for this end? I want to do more than just mazes with this. Yeah, so this policy here is not as good, trained on 48s by 48s, but it should be able to be better if we sweep it. So I think what we'll do... I should just post that as well. And of course I forget to unmute. But there is hammering. So, whatever. Okay, so next we're gonna get this set up on Puffer Box 1. Or Puffer Box 0, I believe. I forget who's on what box. I gave one to somebody, didn't I? Or is one mine? I need to, like, maintain that better. What on earth do we have here? Did I let Bet use this or something? Oh no, it's... Alright. That's fine. This is just me screwing with stuff. Alright, so all I have to do is... compile the torch extensions. Okay. And... is it not Puffer Grid? What's it called? Underscore grid. Alright, we have to recompile some stuff. Can you explain the maze agent? I mean, there's not that much to explain because it's our standard... hammering in the background. It's our standard RL trainer just run on variably sized mazes. And typically when you run RL on mazes, like, you really don't get nice coherent backtracking and other high-level behaviors. It's just like they're really bad at it. It's why it's like a common benchmark. And most of the RL agents you see on mazes have hacked it in some way or another with like rewards or whatnot. We didn't, and we still just instantly solve it. So our latest trainer's pretty darn good, as it turns out. It's mostly the advantage filtering, and the new advantage function, all that new stuff, which will be fully covered in the blog post. But the idea is that you prioritize training over sections of gameplay where there's like, you think that there's something to actually learn from it. So like running into walls repeatedly doesn't teach you anything. So you're going to prioritize sections of gameplay where like something interesting happened. I mean, that's the quick version. If you have specific questions, I can answer them. But it's like, as for like everything that's in the new Puffer agent, there's a lot, right? The key pieces are the new advance. Does it see the entire maze? No. It only sees a very small window around itself. Local vision. It sees like 5 in every direction, I believe. It's like an overhead view, so like overhead 11 by 11, so 5 each direction centered on the agent. I believe that's the default. I mean, but if you've done RL for a while, like, this doesn't happen. Like, that's not a result that you expect RL to get. Like, that's a really good result. A really, really good result. And, you know, a lot of things that should not happen have been happening lately with how Puffer's been going. All right, so now this is going to be a sweep that should include advantage filtering and prioritize replay coefficients in the sweep. It has an LSTM. That's all it has. It has like a standard 1-layer LSTM. It might help. It might help, Captain. I definitely think it's going to be worth, as we get the new versions nice and stable, just redoing some sweeps, rerunning some experiments, and like, it's not going to help every environment, right? If you have like a reward dense environment where like all the experience is roughly equally valuable, there's no reason that this should help. Okay, so this is the other sweep, nicely set up. Now we have 2 sweeps going, and we should be able to go back and see. All right, we have quite some new experiments in here. We see solves as early as 50 mil, and still nothing is faster than like 30-ish seconds. About 30 seconds is, and really, like, this hasn't even done a full solve in 30 seconds yet. But, you know, there's some variety in there. Is this a bot or is this? No, this is real person. You're good. Yeah. You just do. No, you do the work, and I deal with whatever. You're good. I'd rather have those shelves put together. I'd way rather have those shelves put together. Number one shit poster here. How long ago was this? Oh, thanks for the free exposure, man. I think that was when I was at OpenAI, wasn't it? Dude, that's awesome. We baited Yatsine. That's awesome. Dude, that's so funny. Maze looks like it crashed. What happened to our maze stuff? Be ugh, that's not good. I thought we fixed that one. Loss. How's maze policy compare to just A star? A star is an explicit search algorithm with a heuristic. Obviously, anything like this you're going to instantly solve with something like A star. The point here is that this is learned from scratch. It does not have a pathfinding algorithm built in. So this is actually like a pretty darn hard problem to learn for RL, because like learning coherent exploration is quite difficult to do in RL, and this actually just does it, which is pretty awesome. What's the hotkey for scrolling in Tmux? Control B, and yeah, it's this like weird command, right? Hmm. That's kind of weird. efficiency wise, like, you're not really gonna beat A star. And like that's not the goal, right? That's like not the goal and not the point. Because like I can go run this on like Pokemon. It's the same thing we run on Pokemon. I can run it on Neural MMO. I can run this on tons of things where you just can't run A star because like the search space doesn't map to it just doesn't like you can't run A star over arbitrary state space. You can run this over arbitrary state space. So we use mazes as like a benchmark of this stuff. And like a lot of the M's we use in RL, you can solve very easily with like simple scripted agents, though not all of them. The point is that you can also run this on more things. And to your credit, right, I think a lot of RL research has been done on way too simple environments that are just trivially solved anyways, which is why we don't just do that, right? We also have like Neural MMO 3, we've got our MOBA, we have like a lot of different M's that are a lot harder to do that with. But we still use these as well. Hash in the lower right. This is just some weird Torch CUDA failure. Yeah, this is just some like really weird Torch async CUDA failure thing. I don't know why this crashes the program though. I guess it's that if you get this in a probability tensor specifically, it fails. So policy gradient loss. Oops. The noise gate gets most of it. Every so often a little gets through. Wait, actually this shouldn't be possible, right? How can you get... You shouldn't be able to get negatives in the probability. So that is probably actually a bug with the implementation, right? This is probably like one of the optimizations I did. Hang on, let me just bump the noise gate a little tiny bit. It might clip a little bit, but 5. All right. Let me know if that clips. That'll help a little bit. So it's got to be this thing, right? Logits to probs of logits. Unless I call this... Oh, wait. Hang on. You did it again, man. Wait, why do I do this twice? That makes no sense. What was I smoking? What the hell was I smoking? Okay. So, two things we're going to have to do here. First of all... Welcome, YouTube folks. We are currently working on hyperpram sweeps over maze M's, tuning prioritized replay coefficients for the most part to see how big we can solve, how big of a maze we can solve. We just got this result. Hang on, where's the result I just posted? I just put it on X as well. So we just got this result. Pretty solid maze solving agent. And I just think I think I just found the logic bug. That would do it, right? If you passed... I don't actually know. Normalize logits to prob. Let's see if this gets a similar result first. This was like in the 0.660, 0.70 range. This is a nice agent, though. That is the way that we have them set up for now. It would be pretty easy for us to randomize the start and the end location, though, and I probably should do that. But, like, it's not like you just go that direction, right? Like, you can clearly see in the video that, like, it has to backtrack quite substantially to solve it in many cases. And, like, if you look at... Like, if you look at reinforcement learning for maze solving, like, most of the mazes are tiny. They look like this. Or like this. Like, you don't actually often see RL on big mazes. Unless you're using like tabular Q learning on like a single nodes. Like this is, yeah, this doesn't even work. Okay, so now we have probs. And then you do multinomial on this. I guess we'll just see whether this fixes the screw up. I don't even know if this should fix the mess up though. Like how on earth do you get negatives out of a softmax? Like that's weird, right? This is the wrong. Wait. This was breakout that crashed, not. Did they both just crash? This is puffer box 0. Oh, well, this one was me being a dummy. This I just didn't run a sweep. Okay, so here. Dash. So this is now running prio sweep as well, which is fine. And we'll see if these stay alive. To be fair, this was like a pretty late crash. So it could just be something with the normalization. You shouldn't be able to CUDA crash PyTorch by feeding bad inputs to a softmax, right? Like, you should just get loss blow up. Kind of weird. Thank you, yep, seen. We got cited at the bottom of his Ars Technica post. That's funny. Wait. Oh yeah. This is suspicious to me. Oh, that's a different game. I don't know what the routing is in that. That's fun. All right, well, these are running. I think the first run should have been better here. No, no, it shouldn't, because, yeah, this one has different hypers. So this will take a while to do anything reasonable. That's expected. Wait. Yeah, okay, so this is breakout. We have one good run, which is the expected, and then here, this one takes, well, fine. So we'll just have to see whether these are stable, and we'll keep making adjustments as we go. But the main hope for this is that if these are stable, that we figure out prioritized replay coefficients, because what coefficients for prioritized replay are best are going to be quite telling. You know, if any coefficients are good, then it's not doing anything. If, you know, it's a very specific range of coefficients and there's a big fall off, then, you know, there's actually a substantial effect from prioritized replay, and we'll be able to read what that is. The expected result is the expected result would be that it matters quite a bit in it should matter quite a bit in the maze solving and less so in breakout. That's what we would expect to see. We'll just leave both of these open so we can see these. Let's figure out what's next. So it is 2:16. I have an hour before next meeting. We figured out setup. We figured out the sweep issues. We should be able to run sweeps now. And somebody is pulling into driveway that I don't recognize here. What is this? Oh, okay. I just didn't recognize the car. We have, I think the main thing, it was really just sweep ablations, well, sweeps on prio, which we're doing now. We do have to run the full set of benchmarks at some point. I think it's just going to be like general streamlining for a bit. I think we've kind of covered the main big issues at the moment with this. This seems pretty stable. We do have to run a lot of experiments. I'm kind of at the point now where I'm happy running preliminary release experiments, where we like get an idea of how things are going to look and make sure things are sane. But I don't want to lock in final experiments until we have the final version of the code. So it is a good time to... Well, there are two things I want to do, right? There are a few optimizations we still need to make in the main file. And then I think I also just want to take a look at the code base as a whole and see if I've forgotten anything. So that's what I'll do next. I'm gonna grab another drink, do a set or two, and then we'll be back in a minute or two with that. Okay. So, this is still alive. Breakout is... Yeah, those are both still alive. Good. And, not really any good results on this one yet. It's expected that this one will take a while to find decent hypers. So let's just start looking through the code for how everything's gonna fit together for the release here. So first of all, a lot of these scripts are gonna go away, or at least not live here. SB3 demo, I don't think we need this. I mean, if you're using SB3 at this point, you're kind of just trolling. Yeah. Yeah. I think you're kind of trolling at this point if you're using SB3. It's slow, it's overbuilt. I don't think we really care too much about that. We have some C++ files that are mostly getting moved. This will probably go into source as well, but this code will still be here. This elos script will probably just get tucked away somewhere for whenever we decide to actually do something with it, or just delete it, we'll see. We haven't done anything with this in months, so we'll probably just delete this and grab it back from 2.0 when we need it. Some of these visualization scripts, we might include them with, we might include these with the sweeps, because I think we use these for analysis. We probably will keep one cleanRL script, right? Just because, like, cleanRL is really simple. It has a bunch of algorithms for playing with stuff. It's good to, like, compare reference implementations. It's one file. Does it add any deps? I guess technically it adds the tyro dep, which is annoying. That's all it adds. I really don't know why Costa did this. Like, in my view, it's really not worth adding tyro as a dep, just so you can data class your args like this. But Costa's off doing, off solving, like, RL on language models at this point. Costa's awesome. You should totally go follow him if you haven't already. Really great guy. Has he been doing much on here lately? It's criminal that he has fewer followers. He doesn't post that much, but I don't really either, to be fair. At least, the stuff he posts is high impact. Okay, so all these scripts, I don't know if we need these. I think you need this for Raylib builds. We need this build ocean script. And like the rest of these, do we need this? I don't know. Maybe we can kind of just build this into cleanRL. I mean, not cleanRL, we can build this into our defaults or something, we'll see. Configs need to be cleaned up. It's fine for this directory to be wide. And then what I'm really concerned with is all this stuff. We've got like this wrappers.py. We've got this random utils thing. I don't think we use most of this. Do we use this compare? We might use this in test somewhere. Yeah, I don't think we use most of this, so we can probably kill some of it. I know we don't use this. We just got rid of this. We can probably remove most of this, and hopefully even get, like, rid of the utils file, because it's just, like, you don't need a utils file. Sweep we know is good. Spaces. PufferLib spaces is kind of fine. Just has joint space definitions. This will go away when we eventually deprecate gym, when there is no longer anything in gym that's worth using, and everything is either in gymnasium or in puffer. C++ stuff. We know what this is. We already know what we're doing with this. PyTorch functions. Some stuff in here we can definitely get rid of. We also have this old policy pool thing, which we'll probably get rid of for now. I mean, this was a pretty reasonable thing to do. We got puffernet. I think we probably keep puffernet as is for now. We can explore like tinygrad C backend at some point, so we don't have to maintain this, but I don't know, this is kind of cute. Like, pretty short file that just does PyTorch in C is nice. There's this pyx bind. It might make sense to like move this into. I don't even think we need to move this into C API, do we? I guess it would kill the Python dep fully if we moved this to C API. Not as high priority. And we got puffernet.h, PufferLibs, CUDA. Fine. Post processing. I think we use this for like Atari. Yeah, like these are all things we use on Atari and whatnot. So I guess we'll figure out what of these are redundant when we go to like benchmark Atari or whatever. Policy store is currently unused. Ranker, currently unused. I mean, we know we're gonna need this stuff. It's like, do we just like leave it in for now? Or do we kill it and then bring it back? Namespace I kind of like. We have our models file. Just has some defaults in it. This is pretty good. A few small cleanups there. What extensions do we have? Oh yeah, I forgot that we have our wrappers are still in. Our wrappers are still in Python, and it would actually be difficult to get rid of this. So I think we'll keep the Python dep for now formally, but it won't be used at all in the Ocean pipeline. And then eventually we'll get rid of it, but that's fine. That gives me less work to do as well. Some exceptions. I kind of want to just merge all like these little crap files into like a pufferlib.py. To be honest with you. There are too many little files that don't do very much. And like this stuff... Oh, this is because Jim imports everything, right? Yeah, I remember why we have that. That's fine. Okay, and then we have all the environments, which these are fine. We have to go check that they work, but they're fine. Our resources folder could be compressed a bit, but it's fine. And all the ocean M's where we have... Oh yeah, here it is. FFI.buffer. Yeah, this was the function. Cool. We don't need this anymore, but we should probably do something with it or port some of this stuff in. Okay, we can like fix up the to-do list. Clean up. So let's do... old files. Merge all files. PufferLib.py. Pretty much it. We can kind of start on that now. Does Meta use any of this stuff? Let me see if Meta is actually using... if they're using our ELO stuff right now. They probably have their like PufferLib fork or whatever. Yeah, so this is their PufferLib fork. They have the ranker and stuff in here. They haven't done anything with this though. Are they actually using it from here? It doesn't look like they are. Yeah, it doesn't look like they're using any of it. They have this torch profiler. Alright. So I think we have some basic stuff we can do here for the next 40 minutes or so. Okay. We start here. we remove a bunch of old stuff. Yeah, it has not been updated since 2.0. It hasn't been used since 2.0. I think anything that we haven't used and nobody has used since 2.0, we just delete. And then we put back if we want to. I think that should be the policy here. What in the heck is this? Why is this in Git? Exceptions? Namespace, I think, can stay. Does Python have like underscore iter? These aren't built-ins, right? Yeah, I don't think that you screw anything up by doing this. I think we leave spaces. Oh, actually, a good rule for this would be if this can go in the default imports, right? Yeah, if these can go in the default imports. So by that logic, what else can go in the default imports? What else can go in here? The clean RL. This is dated. Yeah, we don't need this anymore, right? All right. Post process just has a gymnasium depth. We can move this in. That's so much easier. Okay, so emulation is its own thing. Environment. This actually... Is there any reason that our custom environment can't just go into PufferLib.py? It cleans up our imports. It should be fast because we don't have any like heavy dependencies in here. Right? I say we do it. Now the only one I don't think we move is spaces because like there's gymnasium.spaces and PufferLib.spaces. So for the consistency of it, I think we leave spaces alone. And eventually spaces.py gets deleted, right? When it gets deleted eventually when we eventually drop gym support. Like that's gonna go end of life, right? Nobody's maintaining that. It's only 96 lines. Okay. We no longer have to import this because it's just there. Cleans things up nicely. 450 lines. Okay, so emulation is staying absolutely where it is. That's a whole bunch of stuff in there. Models is absolutely staying where it is. We got the PyTorch file. We do not want a torch depth. Sweep is its own thing. Space is its own thing. Vector is its own thing. The goal is to just not have any more like stupid little piddly files just like floating around everywhere. It's like you have 100 lines of code somewhere and it goes in PufferLib. And it doesn't need its own freaking file. So I think we can check utils. I think we start grepping stuff here, right? Because we can't just copy this in with all these imports. So we'll do grep. Not used. We can just start deleting stuff that way. Check two small things. let's double check here as well. They both seem to have crashed. Lovely. So we got some sweeps out of it. Doesn't seem to do very well there. And here, this one is also crashed. So we take a break to go figure out what happened here. Probably the same bug, right? Yes, this is the same bug. What are the odds that this is my kernel? Low? Low, I would think, right? I thought it was Control B. What's the scroll key? I always forget, like, Tmux has weird commands. Control B and then the other bracket. I had the used the wrong bracket. Okay. We get CUDA error here. Train on profile.train forward. Desynchronize. This does happen after the sample. Wait, after the sample? Sample does not call synchronize. Sample does not call synchronize. Probability tensor. Oh, you know what this would be then? I think we found it. So if you have sampling in here and you're using prioritized replay, you do probs plus 1e minus 6. So if your advantages explode, then your probs explode. And then you break sampling here, right? Okay, so we have to figure out a way around that, because that's really bad. We could just check advantages for like any's or inf, I guess. And we could break out there. That seems sketchy. Hang on, so why is it that you can't... Oh, wait. Advantages... These are not probabilities. Aren't these supposed to be logits?